welcome to this webinar hosted by UReason. In this webinar, we will look at how digital twins can help you in the world of data-driven maintenance. And this short webinar has four parts. First, I will introduce the company UReason. After this, I will go into detail on the different types of digital twins, the elements that make a digital twin, and the criteria for digital twins to be used in data-driven maintenance initiatives. And then we have a look at some of the examples of digital twins that we have been active in with UReason. And this is followed by Q&A. So at any point in time, if you have questions, just pop them in the chat. And at the end of the session, all the questions will be answered. Okay, a short introduction. I'm Jules Oudmans, presenting to you today. I have a background in AI starting in the 90s, and I've been involved many times in the past 25 years in prognostic and predictive programs that ensure asset integrity for critical assets and critical processes. I have a mixed background in physics, mechanical engineering, and computer science, and my motto is I like the famous coffee one, digital, what else? I work at UReason, a software company that provides solutions for real-time condition-based and predictive maintenance, and I help our customers daily to use our software from data analysis to the setup of applications and solutions that monitor important assets and processes. At UReason, we combine our domain expertise and software knowledge with our customers, and I help them from data to solutions. We have offices in Rotterdam, which we see here in the pictures, and in Wokingham in the UK. Our customers are predominantly in the manufacturing and process industry, and the majority of them are located in Western Europe and the North Americas. Our software, APM Studio, is used at different levels in the automation pyramid. It can be used embedded, that's done predominantly by OEMs, monitoring faults and risks in isolation to the asset. And an asset can be instrumentation, an actuator or a pump or a compressor filter, etc. We also work at the edge, close to the assets, processing asset data of one or multiple assets to run condition monitoring and predictive applications near to where the data is generated. And we also work at level 2 and level 3 in the automation pyramid, where APM is used to monitor faults in relationship to the process, deployed or running on on-premise compute most of the times. When deployed at level 4 and level 5, APM Studio is used for optimizing the maintenance cost and planning associated to an asset base that is supporting a process. Now, UReason is active in real-time condition monitoring, predictive and prescriptive maintenance, and our field of operation is from helping customers to insights into data, to helping asset owners and OEMs, and maintenance service organizations with data-driven maintenance solutions. Often we start together with our customers to define the business cases and use cases to focus on, followed by data collection, model development, and deploying the solutions into the existing OT and IT landscape. We work and deploy our software, APM Studio, for manufacturing companies. This is about 40% of our business, and we work a lot with OEMs and skid builders. For OEMs, their focus is to maintain margin, provide data integration, new service and business models, and staying relevant for their customers. They typically focus on the value of the asset. For asset owners, their focus is to lower energy costs, reduce plant maintenance, reduce reactive maintenance, stretch asset life, balance risks, and optimize the planning for their asset base. For asset owners, it's all about the value of the asset that is supporting the process. So in today's webinar, I want to introduce the topic of digital twins. Digital twins get a lot of attention in the media, and I would like to break this down in this webinar to what it actually means, what digital twins mean, and how to apply them in the world of data-driven maintenance. There's a lot of unclarity, in my opinion, about what a digital twin is, what they are, but ExxonMobil released a pretty nice picture, an infographic that explains it in the right way. In this Venn diagram, we see that a digital twin is composed of models and simulations, modeling a process or the dynamics of the process, a visualization, modeling the look and feel of an asset or a process, the thermodynamics, for example, and a part of data integration. And this picture explains digital twins quite nicely. But in this webinar, stay with me, I will continue on explaining digital twins and now also how to implement them. Um, to top the ExxonMobil Venn diagram up for digital twins, there's also an ISO standard that most people don't know about. This ISO standard describes the concepts, limitations, boundaries, and the requirements, but it also provides reference models and different views, functional, informational views, and network views on digital twins. I mention this because most of the customers we work with are unaware of this standardization effort, which can help you create clarity. Even though there is an ISO standard, I like the Gartner definition better because it's more concrete. Um, Digital twin brings an exact replica in digital format, so in software format, of a process, a product, or a service. And basically, it takes real world data about a physical object or a system as inputs, and it produces in the form of predictions or simulations of how the physical object or system will be affected by those inputs. And the most common use cases for digital twins that we see are visualization of products in use by real users in real time, troubleshooting of remote or inaccessible equipment, um, management of complexities and linkage within systems of systems, and connecting disparate systems and promoting traceability. Now, there are different types or levels of digital twins, and these have different use cases, different use scenarios. There's the component twin at the bottom of this slide. For example, that represents a bearing, a piston, an axle that can support field services technicians to continuously monitor and offer predictive maintenance insights while reducing equipment downtime, planned and unplanned, and enables service-based business models. One level up, we have an asset twin, for example, a turbine, a motor, a control valve that can support product management, sales, to gather knowledge on customers' preferences and actual usage of their product and provide new service business models to drive revenue. One level up from this is the system or the unit twin, which is, for example, a crude or reverse osmosis unit that helps product designers, architects, and engineers to improve future product versions and engineering models to optimize product performance and efficiency to accelerate the time to the market. And then at the top level is the process twin, for example, a composite manufacturing process, helping management to get new operational data feeds into production and planning models, thus paving the way for strategic insights, recommendations, and roadmaps. Now, a digital twin consists of four main elements. There's the physical equipment, the actual equipment item or items that we're interested in creating the twin for, or the actual unit or process system. Then we have the twin model, the software model consisting of a hierarchy of systems, sub-assemblies, and components that describes the twin and its characteristics enriched by asset operational, historical, and context data. Then there is knowledge with data sources that feed the twin with operational settings, domain expertise, historical data, and industry best practices. And then, of course, there's analytics, simulation, and or machine learning models. These can be physics-based models, statistical models, and machine learning AI models to help describe, predict, and prescribe the behavior, current and future of the asset, system, or process. Now, in the screenshots in this slide, I'm showing various parts of our software, APM Studio, that is used to set up digital twins. Now, let us have a look at some examples of digital twins that we have set up with our software. Here we see the Focus One device. It's a control valve with onboard pressure, temperature, flow sensors. So it's more than just a regular control valve. It has onboard an asset digital twin built in our software, APM Studio, allowing cruise control in asset management by providing embedded diagnostics, embedded soft sensors for critical measurements through digital software twins, and it is capable of reporting what process conditions are taking place, such as cavitation, flashing, and what the maintenance field support is required to do. So this digital twin, asset digital twin, allows companies to optimize their maintenance planning because the device itself runs models that indicate when maintenance activities, inspection, calibration activities are required. And it embeds our software to provide, for example, soft sensors for critical measurements that are being made on board, which are true digital twin representations of the actual measurements that can take over when measurements fail. Another example at the unit level is one at KUKA, where our software, APM Studio, provides recommendations in remaining useful lifetime of tools that are used in the production sensor, which is put in relationship to the jobs that need to be run on the centers, the production cells, within given time and time frames. Now, digital data twins and AI models support the site to have less disruptions during unmanned production periods, and it increases overall the output of the cells in the Augsburg facility. So this is again a digital twin, one at the system level, so one level up from the previous example that takes into account a unit operation, a number of unit operations at this site, where twin models are being used to provide predictions on remaining useful lifetime of the tools at the center used in the production cells. A process twin, again a level up. Example is one at Airborne in the Netherlands. Here, AI models are used that predict the gap width of the laminates that are being produced to help operations and control to make inline adjustments, reducing scrap and improving overall output. Again, this is an example of a digital twin, but one that involves the process side, the asset side, and uses different machine learning models to determine quality defects that would normally lead to scrap. That allows operations control then to actually intervene, or the systems to intervene at the right point in time. Now, not all use cases or business problems can be effectively solved by predictive maintenance using digital twins. Digital twins are not a cure to all illnesses as such. The important qualifying criteria that you need to consider during the use case qualification for digital twin projects are the first one, an obvious one. Data from the field can be extracted and enhanced to provide further insights higher in the chain, higher in the process. A second criteria is that the problem must support a business case, meaning that there should be a target or an outcome to predict or calculate that is of value to operations. And preferably, the third criteria, the problem should have a record of operational history of the equipment that contains, or process that contains, both good and bad outcomes. And finally, the business should have domain experts who have a clear understanding of the problem. That's very important. You can't magically create digital twins without the knowledge component. Referring back to one of the previous slides, knowledge is one of the very important inputs for digital twins. Now, the steps to realize digital twins are quite logical, but still, I've listed them here on this slide. Think before you begin. It's not about trying new technology, but selecting a digital twin that provides value to your organization, business, and/or customers. Value can be a reduction of planned maintenance, creating longer preventive maintenance time horizons, knowing hourly or daily what the risk and associated cost of operation is, etc. So there has to be a value. The next step is to build and realize the digital twin. And what we saw in the previous slides is that you need access to data streams, access to the data from the physical assets and processes, historical data, and you need knowledge and simulation models and criteria. For example, I want to know where on the PF curve my asset currently is. Validation, of course, is key. Hence, you will need to have historical data. Once you've successfully validated, you can deploy and embed your digital twin in your processes, but you do need to monitor its performance and deviations and embed the lifecycle management of your digital twins in your organization. This is an area that very often, or in many cases that we have encountered, is overlooked, is overseen, and it is quite an important aspect that you need to take into account. Now, let me summarize. This is one of the short webinars of UReason, so we try to do all the content in 20 minutes. So, keeping a close eye on the clock, we're doing quite well, such that we also have time for questions, and I see some questions coming in. Let me start with the first summary, which is that digital twins are not a myth. There is, as I explained earlier, and we will also share all the slides and also the replay, there is a standard that helps you, guides you in terminology, structure, and different information models. So um, uh, when you start, and if you don't know where to start, how to start, I recommend that you get the ISO standard mentioned in the slides. It helps tremendously. Another thing to realize is, in summary, that there are different levels of digital twins, and I showed you a number of examples of digital twins at the asset level, at the unit level, and at the process level, the top level. Um, Digital twins, when you start with these types of programs, you don't need to start with process, the highest level digital twin. You can actually start, and I would really recommend this as well for the audience, with digital twins at lower levels in your process. Of course, there has to be a business case. Again, there has to be a value for doing that. But I would really recommend that because that simplifies your project. If you start with a process digital twin, let's say it's on a chemical process, there's many influences of the chemics in the process, for example, itself, that can influence the proper working of your digital twin. And before you start, um, reflect on the criteria that I shared with you for starting a digital twin. And I can also recommend before you start to have a look at the article that was published today on our website on how creating digital twins can help you run your plans better. It's an informative article, takes you what 5 to 7 minutes to read, but it's really worthwhile. Now, let me point out to you that we have a digital twin model that we also appified. So we created an app from it, which we call the Valve app, which allows you to get easy insights into the control valve performance and make the right decisions in asset management and asset planning about the remaining useful lifetime of your control valves, your actuators, the positioners. And this is really a step forward again that we're making. We introduced at the beginning of this year a pump app that is combined with Phoenix Contact hardware. Um, that is, as we experience it, still a big step for customers to engage with because hardware is required. There's a management of change process. The Valve app, the basic version of the Valve app, can be used just on historical data and provides you with a lot of valuable insights on your control valve performance. And it works both for electrical actuators and for pneumatic actuators with a variety of different valves, globe valves, gate valves, etc. So if you're interested in this, please reach out to us or to me, and we can provide you with further details. Now I see a number of questions have already come in, so I'm going to move to this next slide, which is the Q&A slide. And I'm just going to scroll. I have a number of windows open here for running the webinar to the first question, which is by Michelle. And I'll read out the question. On one slide, I read in a low/no code environment, and it refers to the context in which APM Studio can operate or to one of its characteristics in terms of usabilities for the client? Well, Michelle, let me quickly go back to that slide. I think I know which one it is. Um, there's a lot of slides coming there. It's actually this slide. So APM Studio is an environment which provides to the users a low-code, no-code environment to set up digital twin models, but also diagnostic prognostic models that can obviously run on streaming data, on real-time data, but also on historical data. And typically, a application that is built in APM Studio is deployed on hardware or on a virtual machine or in the cloud. And by deploying an application, you make it live. So let's take a use case scenario where APM Studio is connected to streaming data. APM Studio is the environment in which you set up your APM application, and then you can deploy it to multiple different targets. Embedded for OEMs, quite interesting. On edge, on-premise, and in cloud. If you have an application running with APM, the APM Studio environment can also be available to super users or administrative users to adjust in real time also your control flow logic, your diagnostic models, the ML models that you have loaded, etc. So it's in terms of usability, it's important for the client that it's low code, no code, because the client normally has experience let's say in their domain, they have domain expertise, which could be in pharma or specific to certain assets like compressors and turbines. And our environment provides them a very easy way to create cause-consequence models that run on live data, embed machine learning models on the streaming data, etc. I hope this answers your question. Um, Let me go to question number 2, again from Michelle. With regard to the data collection, is it possible to have a brief description of what are the necessary requirements to interface APM Studio with customer systems? Which protocols and interfaces can be interfaced with? Okay, so I actually don't have a slide of this in the deck, but we within APM Studio you can connect to quite a variety of different protocols. So we can get data from the field level via 420 milliamp and HART. We can get data from the field level via Modbus, Fieldbus, Profinet, Profibus, etc. So the most commonly used industrial interfaces are available, as well as the ones in the discrete world, IO-Links, for example. And on top of that, you can also connect APM Studio to data sources which are, for example, more database based, so to time series historians such as Pi, IP21, Exaquantum, etc., which provide near real-time data, normally updated at a second or 10-second interval. And then we also, of course, on the cloud side, we have connectors for Azure IoT, um, um, and for different other providers as well. So there's quite a variety of different interfaces available within APM Studio as different modules that allow you to connect to the field level, but also allow you to connect to SAP PM, SAP IoT, Ultimo, Infor EAM, etc. So there's quite a wide variety of data interface capabilities available also in a low no-code environment. And why do we have so many interfaces? The answer is simple. Everything starts with data, and we need to be able to interface to that. Now, let me go to question number 3, which is from Theo. The maintenance links is obvious. Are digital twins also used for new employee training? Yeah, so that's a good point, Theo. Digital twins are also used for operator training simulation or field service personnel training simulation. There's quite a variety of different use cases. In the past, in UReason, we have built training simulators, for example, for end customers using physical models in combination with knowledge models. This is not an area that we focus on anymore, but it's definitely worth mentioning that the digital twins can also be used for training purposes. I do want to point out that within APM Studio, you can also replay data. So you can replay data that sits in a data historian somewhere, in a database somewhere. And this is very often used by our customers for what is called scenario reenactment. So for replaying scenarios that happened in the past, and allowing then users to interact with the process to see what would have happened if they would have acted differently. I'm jumping to the next question from Michelle. And Michelle has a lot of questions, but that's good. Michelle, a description on the use of a digital twin applied to the monitoring of the parameters of the devices that govern an automated process in which I have several PLCs referring to different technological devices. Okay, so the question is, can you provide a description on the use of the digital twins applied to monitoring of parameters that oversee a variety of different devices? Um, yeah, so maybe I'll use an example of soft sensors. Soft sensors are software-based sensors that, for example, has been trained on the basis of historical data. And these allow you to oversee the functioning, the proper functioning of devices. And one of such examples I had in the slide deck as well, the focus of one device. Let me just scroll to it in the slides. Give me a second. There we go. The Focus One device uses soft sensor technology and some other capabilities as well inside APM Studio to provide backup calculations, redundant sensors, but soft sensors, for specific critical parameters, critical sensors in the device that when they fail, the operation of the device needs to continue within certain bandwidths. And this is where the application of digital twins at the asset level can have a very nice benefit for users. Of course, I mean, this is an example at asset level. You can apply the same type of model at higher levels as well, using soft sensors. Now, another question from Michelle. Can I use APM as a supervisor software, for example, over a SCADA? Yeah, so a SCADA supervisory control and data acquisition system is its role typically is to provide information, field type information, alarming information from, well, whatever is at the control level, typically at the PLC control level. And APM could be used, for example, to oversee the right actions or the right expected actions that are taken using a variety of different tools that we have available inside APM, such as decision support techniques that can track and trace the actions that are being taken by the users. So it is possible, absolutely. I'd like to understand better what the use case is. So perhaps um, we can have a more how do you say it detailed conversation about this. And let me just check with Toe. Okay, super. I see that there are no more questions. While Toe is reporting there are no more questions, so I've been able to finish very well within the time frame that was given. We had half an hour, and I knew I had a lot of content to share. But rest assured, the slides that I showed will be shared after the webinar, as well as a replay link. So To and Arthur, the moderators here in the session, will send you the slides, the replay link, and we'll also do a follow-up with the people that are interested in this as well. Again, thank you very much for the time you've taken. There should also be, and I'm just checking with To, a evaluation form. That evaluation form actually starts as soon as I stop the stream. So when I stop the stream, stay on for a minute. less than a minute, to provide us with some feedback on this webinar. And I hope to see you again in the next webinars. And again, a short one, and maybe we stretch the time frame a little bit so that we have more time for questions and also more time for content. Again, everyone, thanks for attending, and I hope to see you soon. Take care. Bye bye.